Welcome everyone and thank you for joining us for today's GraphRAG workshop. My name is Samriddhi and I'm part of the virtual event team here at Neo4j. I'm thrilled to be joined by Siddhant Agarwal, Tech Community Manager, Developer Relations at Neo4j. Siddhant is a seasoned DevRel professional with over a decade of experience cultivating innovation and scaling developer ecosystem globally. Currently leading developer relations across APAC at Neo4j and recognized as a Google developer expert in GenAI. And we are super excited to have you all with us today. Just a quick note about questions before we get started. We invite you to submit any questions you have throughout this session using the questions tab located at the top of your screen. We'll answer as many as questions possible in between and at the end of today's session. And if you don't get to them at all, someone on the Neo4j team will reach out to you directly, or you can send an email to webinar@neo4j.com and we'll get you pointed in the right direction. So, with that, I'll go ahead and hand it over to Siddhant.
Lovely. Thank you. Thanks so much, Samriddhi. Thanks for that introduction. Hello, everyone. Good morning, good afternoon, based on the time zone that you're joining. I'm hoping that everyone is from APAC, so apologies if it's not in your time zone. I hope you all can see me and hear me as well. If yes, can you use the Q&A section to just give a yes, if you can hear me, if you can see me. Just want to ensure that we are on the same page. Okay, super, lovely. All right, so thank you once again for joining in for this session. Let's quickly get started. We're going to talk about the GraphRAG Python package today. This is something that Neo4j launched earlier. If you are familiar with this package, you might know that earlier it was named as Neo4j-GenAI, and then we recently renamed it to Neo4j-GraphRAG. We're going to cover up the RAG aspect, some of the core concepts, and then we'll also dive into the Neo4j-GraphRAG Python package and how it works. Without further ado, I'll quickly get started. So for this particular workshop, we're going to use a platform called Graph Academy. It's a platform where all our content, our training courses, everything is available under one roof, and then you can access it from there. So this is the web page. This is the platform that we're going to use for learning how to implement GraphRAG with Neo4j-GraphRAG Python package. I'll request somebody to share the course link in the chat window in the Q&A section. Just publish it. Okay, I will also do that. Okay, the link is with you. Check the publish section in Q&A, and you should get the link. So that's the course that we're going to get started with. I'll jump on directly to enrolling in the course. If you have not signed up on Graph Academy, you would need to sign in and then enroll in the course. So once we enroll, let's wait once we enroll in. Okay, cool. So as I said, we're going to cover up certain aspects which are critical to RAG, to understanding RAG. We're not covering up Neo4j fundamentals over here. So again, apologies if you feel that we are not covering up Neo4j fundamentals. That's for a different webinar. Towards the end, we're going to share you the link for the second session of Neo4j fundamentals. We have already done Neo4j fundamentals earlier last month, if I'm not wrong, last month or last month. And we're going to do another session of Neo4j fundamentals in April. So we're going to share the link towards the end. So this particular workshop is dedicated on RAGs and Neo4j GraphRAG Python package. So we're going to learn about vertex indexes, how to use them to search for similar data, how to create embeddings and vertex indexes, vector indexes, sorry. And then we're also going to create a graph with unstructured data using Python and GraphRAG Python package. So let's quickly dive in over here. So if any point of time you feel my pace is a little fast, just let me know. But the session is also getting recorded, so you can watch the recording later on. So for this workshop, we're going to use, you have two options to use. Either you can use the GitHub code spaces, or which will open up an environment for you and where you can directly get a browser IDE and then run everything from there. Just give me a second. There's a power cut, and then probably because of that, you're seeing a switch in the windows. Um, right. So you can use GitHub code spaces. That's one option. Another option is that you can develop on your own local machine. So you would need, if Python is installed, you can follow these steps and then clone the GitHub repo that we have already created for you. You might have to install all the, you would have to install all these packages as well before you proceed. So it's optional. If you want to develop on your local machine, you want to run everything on your local machine, you can follow these steps, do a git clone, and then install the Python package, install the packages that's needed for this particular workshop. If not, you can directly head to open in GitHub code spaces. And once you do that, just create a new code space. Make sure that you're logged into your GitHub account. We initially had this on Gitpod and then migrated to GitHub Codespaces recently. What it does, it creates a virtual environment where your browser loads up the entire IDE, all your all the GitHub content gets cloned automatically, so you don't have to worry about anything. It also runs your requirements.txt as well. So everything is there structured for you, done for you with just a click of a button. So let's wait until this gets started. So meanwhile, this particular workshop is divided into two modules. As I said, one is where we're going to cover the core concepts. We of course do some hands-on in the first module, and the second module is where we're going to do learn about the various retrievers that we have in GraphRAG Python package that we have built for you. Okay, it's taking. Okay, it's done. So our package has been loaded. Our repository has been cloned. Everything is done. You see there are two modules. The first module has a couple of Python files that we're going to execute. In these Python files, we're going to learn and then execute as well. But if you want to just run the, these Python files would be kind of like a boilerplate code. And if you want to run full solution, you can just run the solutions files as well directly, which has the complete content over there. And same goes for the second module as well. So let's see if our environments and everything is loaded. But before that, we also need to create a copy of this .env.example file. So let me just go ahead and create a new file. Just a second. Okay, I am just going to rename this one to .env. And you will see you have an option to add an OpenAI API key, and then there's URI, username, and password that you need to feed in. For this workshop, I am going to share with you the OpenAI key, but you can go back and use your own API keys as well. I'll ask somebody if you can share the link to Google Docs, which has the OpenAI key in the chat window, and publish it. Meanwhile, this is the OpenAI key document that you will see. Just gonna copy it and paste it in my .env file. And then for URN, username, and password, I have to go back to my Graph Academy page and scroll down. It automatically creates a sandbox instance for me where I just copy the credentials from there and paste it in my .env file. All right. So once this is done, let's make sure that our instance is loaded correctly. Everything is set up. We just want to test our environment. Just a second. I'll just quickly check if you've got the API key or not. Okay, I will share the API key. All right, there was some internet connection issue. I think everything is sorted now. Let me go back and see if everything is working fine. Okay. All right. So we're going to test the environment file. There's a test environment file, Python file that we're going to test and see if our API key, URI, username, and password, everything is being correctly entered in. And you can see that we ran 5 tests and then everything is okay. Now let's switch back and then move forward from there. Okay, so when we talk about generative AI systems, we often use vectors and embeddings to represent and understand our data. So what are these vectors? These are basically a list of numbers. They can represent many things. They could be your images, they could be your text, it could be your audio, it could be anything. For example, over here that you see is a list of 3 numbers, which is representing a point in a 3-dimensional space. But in a real world situation, in a rather a GenAI system, in an ML system, these vectors can be used to represent. These can be of multi dimensions, or maybe thousands and hundreds of dimensions. And it's pretty common in a GenAI system to have thousands of dimensions for a vector. And again, when we talk about GenAI systems in the context of GenAI applications, we use the term embedding for vectors. It's simply a way to map your complex data, like your words or sentences or images or anything, into vectors, which can further be easily processed by machine learning. For example, when you look at the embedding for the word apple, it might look something like this, and maybe longer than that. Um, and we use specialized ML models, which we call them as embedding models, to generate these embeddings for words and phrases in a language. Again, these are trained on large amounts of data, where these embedding models can then further help us to generate embeddings for our words and phrases. In the context of GenAI systems, we also talk about semantic search. What is semantic search? It's uh, different than your keyword search, traditional keyword search, where you're talking about where we're trying to search the exact match keywords um, uh, for your search query, but rather you want to find similar or semantically similar results. So that's where semantic search comes into picture. So if I'm trying to query for Apple iPhone, I would like to return results about Apple's iPhone and not just Apple or maybe iPhone. I like maybe any other brand who is creating Apple iPhone, for instance, right? Now, there are ways to find similar vectors. Um, if I'm putting a search query, it gets converted to a vector, and then it goes and searches against the other vectors. Now, there are ways to find the semantic between two vectors. I'm not going to go into the depth of mathematics about it, but if you're interested, you can search more about it. Ultimately, you use the distance or angle between the vectors to catch the semantic similarity between words or phrases. So that's that, and let's jump on to the next one where we're going to search using vector index. So our sandbox has preloaded movies. It has 1,000 movies, and we have already created embeddings for movie plots. So these movies also have a bunch of other information, and we have created 1,000 embeddings on 1,000 movie plots. So if you run this Cypher code, you'll see some of these plot embeddings in movies as well. Okay. All right. So there's 1,000 movies, and there are movie plots as well on which embedding is created. Now, if you want to search for a specific movie, let's say Toy Story, we can just query and see for the Toy Story, this is the plot. And if I go and run the next snippet, it will give me the embedding for this particular plot. So this plot has been converted into an embedding like this, something like this. It will have probably thousands of vectors. Okay, and if I want to search for similar movies which have a plot similar to the movie Toy Story, um, I have to just run the snippet, and it gives me all the movies which have a plot similar to Toy Story. So Toy Story, of course, will have 1 or 0.99, which is closer to 1 already. Um, of course, that's there. Then there is Neverending Story 3, um, The Little Rascals, Gumby, for example. There are a bunch of movies. I've given a limit to 6. So in this particular query, I have put in a limit as 6 that I want to return 6 results, search against my plot embeddings. And this db.index.vector.query nodes is the procedure that we're going to use to search our vectors, where this vector index movie plots already exist in our database, and then we are searching it against this plot embeddings. Now you can go ahead and change the title and see what kind of results you get. So for example, if I want to find all the movies which have a similar plot as Jumanji, I can just go in and then change the title to it. Title over here, and then it gives me, of course, Jumanji, and then there is Escape to Witch Mountain, which is kind of, I agree that it has almost similar plot. This Mortal Kombat, again, a bunch of other movies as well. All right, let's jump on to the next one. So far we have touched base on what are vectors, how do you do semantic search and embeddings. The next is what we're gonna learn is how to create embeddings. So we have already created embeddings for our movie plots, but how do you create embeddings on the go? So that's what we're gonna learn in this particular exercise. But before I move on, I want to quickly check if there are any questions so far that I can take up. I do not see any questions. Okay, fair enough. Jumping on. So as I said, we're going to use Cypher to create embeddings, and then we're later going to use Python to create these embeddings as well. So we don't going to run this one directly. We're going to copy this, and we will be pasting this. Here, what we're going to use is update the token here and update it with the OpenAI key. OpenAI key is already there in the in the chat, in the Q&A, in the published section. So we're going to use this OpenAI key, and this is just a random text. This says like text to create embedding for. Just randomly, we're going to see how the OpenAI creates an embedding for this particular random text. So this is the embedding for the text, which says text to create embedding for. Now, as I said, instead of searching by the title, if you want to search it with a specific movie plot, where we just know the plot and we want to say that, hey, this plot uh, is what we are looking, and someone will get the movie titles which are similar to this kind of a plot. I just know that, hey, there's a mysterious ship lands on Earth, but I'm not sure what was the title of the movie. In those situations, we can convert this particular um, text into an embedding and then search this against the existing embedding that already is there in our database. So again, we're gonna put our API key and update the query and run the snippet again. Now this gives me that a mysterious ship lands on Earth. The query that you're asking, probably you're asking for a movie which says 2001: A Space Odyssey, or you might be asking for Alien. So this plot has a similar plot with the existing movies that are there in the database like this. So you can go ahead and test it out with different movie plots and observe the results and see what you get. Okay, so moving on, next is to create a vector index. Now, if you recall that we had already created a vector index for movie plots, and that's why we were able to query using our previous snippet, where the vector index was already created, vector embeddings were already created, vector index was created on top of it, and then we were able to query. And then in this particular exercise, we will be creating a vector index, but the vector embeddings would already be there for you. So similar to movie plots, movies also have movie posters. Now these movie posters will be having some embeddings as well. So we had converted each of these posters into an embedding and then stored it into the database already. That is preloaded into Neo4j sandbox instance. So if I go and run this particular snippet, it gives me a URL for the movie Toy Story, which is nothing but just the poster for the movie Toy Story. Now, this how does the embedding looks like for this particular poster? It looks something like this. It's going to be different from the plot embedding. So this poster embedding and the plot embedding would be different for sure. Now, the embedding for this particular poster vector posters doesn't exist. Sorry, the indexing on the poster embedding does not exist so far. So what we're going to do is we're going to create a vector index on the poster embeddings property for our movies. So once we run this, it creates a vector index named movie poster um, on the poster embedding property, and it puts in some configurations like dimensions as 5 and 2 and similarity function as cosine similarity. Now, if you want to see what all vector indexes are there in my database, I can just simply run this and see what vector indexes exist in my database. We know this for a fact that movie plots is one of the vector indexes that exists because we tested this in the previous exercise. And then there is movie posters that also exist in my database as another vector index. Now, similar to what we did in the previous one, if you want to, let's say, search with the posters and say that find me similar posters to a particular movie's poster, I can give a title and say, find me all the posters which are similar to this. So we know we have got one poster which is for the same movie itself, which is this. And then for the other movies, we got the other two posters as well. You can go ahead and try it out with the other movies. Probably you want to change it and say, maybe with Jumanji, how does the looks like? Jumanji, of course, you'll get, and then you'll get also, let's say this is Jumanji's poster, and then Jungle Book is this. Pretty similar. You have animals, you have humans, everything. So yeah, did a good job. Okay. All right. The next query is just to see what all movies have poster embeddings. All the 1,000 movies have poster embeddings. They have posters and then they have poster embeddings also. So let me just skip this and then move on to the next one, which is full text search. Now, although semantic search is very commonly used for matching your user queries to text in a database, but it definitely has some limitations. So when I know that I want to find semantically similar, semantic search is good. They have similar in meaning. For example, two pieces of text like the child is playing with a toy, or kid is having a fun with plaything. They're considered semantically similar because they both represent the same thing, although they have different wordings, if you notice. But if I want to find some exact references, exact keywords as well, that's where we're going to use the full text search. For example, if I want to query what is the name of the actor in the movie, The Matrix, or who starred in the movie, The Matrix. Here I'm very specifically talking about the movie, The Matrix. I want to make sure that the matrix, the word, the matrix should be there existing in my database, then only give back the results to me. So in those cases, we want to go with a full text search. Um, or for example, which movie is set on Tatooine. No, this only has a meaning within Star Wars universe, and won't return anything by semantic search if Tatooine wasn't present in the training data of the embedding model. So in those cases, we want to use the alternative method for searching text, which is full text search. Now, we can, of course, combine semantic and full text search to do something called as hybrid search. It's really powerful when you use the capabilities of both semantic and full text search, and run it across the results that you're getting, and then combine the results from both. There's a way to rank the results from semantic search, rank the results from full text search, and then give back the results to you, which are combination of full text and semantic. So now later in the lessons, we're going to use how to use hybrid search in our RAG applications. But for that, we also have to create a full text index that we can later use to query on our data. So now, if you recall, we created embeddings on our plot, and those were already stored. But since we are going to use full text index, we do not want embeddings anymore. We just going to use the plot and then create a full text index on top of this particular plot property. So if I run the snippet, it creates a full text index called plot full text, if it does not exist, for each movie and its plot. So that if I'm searching for exact references of any words, it directly goes and checks within the plot if the exact references exist or not. And if I want to see what all full text indexes exist in my database, I can use this particular cipher command called show full text indexes, and it gives me that plot full text is one of the full text index that's there. It's only one index for now. Okay. Um, Then, similar to the way we query a vector index, we query a full text index. But again, as I said, we do not need a plot embedding over here. No embeddings are needed for a full text search. So if I just call in this particular procedure called db.index.fulltext.query nodes, and then query it against all the full text indexes. And this is my query where I want to search for a specific reference of 1375 Imperial China in my plot, and get me all the plots and titles which are similar, or rather will have the exact reference of this particular these words. It could be in any order, by the way, but I should get the exact references, exact words in the plot. So if I run this, I get this particular movie which says Musa the Warrior has exact references of 1375. It has Imperial China as well, while the others have maybe China, maybe have the word imperial, for example, over here, but it do not have the exact words 1375, imperial, and China within the database. All right. Now let's move on to the next one, which is unstructured data, but I'm gonna pause over here before I jump onto this section and see if there are any queries so far. Okay, can we create a key for GraphRAG trials later on? Uh, I didn't get that. What kind of key are you looking for? If you're looking for an OpenAI API key for this particular exercise, then until the end of the day, you will have the key with you. But it gets um, kind of discontinued after the workshop, and I need to double check on that. But yes, like until the end of the day, hopefully you should be able to use this OpenAI API key. But later on, you have to use your own OpenAI API keys. How do we create vector index on existing graph in Neo4j? Okay, so I think this has already been answered in the exercise. You can use this particular. So the way we created a vector index on movie posters, you can do that. So you need to have the embeddings first to create a vector index on top of it. So since plot embeddings were already there and the plot vector index was also there, we created a movie posters vector index here. I hope that answers. Okay, do you have a session, do you have a Neo4j session to handle time series data? Well, we do not support time series, as far as I know. So there won't be a specific session as far as I know, but there are ways to handle time series data. You can find something on YouTube for sure, on Neo4j YouTube channel around how to handle time series data. How do we rank between full text and semantic search? That's a good question, Eric. That is something that I'm going to cover in a while. How does Neo4j tries to understand which, like, how do you rank between full text and semantic? It's a combination of two. So what kind of results you get from full text and semantic, that I will be covering up in a while. So allow me some time on that. Okay, I hope that answers, Eric, for now. The next one is once a vector embedding and vector index got added to a node, if relationships gets newly created or deleting existing one, will vector embedding and vector index be getting auto updated, or does it need manual triggering? So vector embedding is kind of like a property on your node. It has no connection with your relationships. While it does help if you're querying something which has a, I mean, combination of fetching information from relationship and a property on a node, it might help in that scenario, but it, it doesn't have any connection between your relationship and a node. So your vector embeddings and vector index are on a node, not on relationship. So newly created relationships or deleting an existing one will have no impact on your vector embeddings and your vector index, because ultimately they are on a node. I hope that answers. Okay, the next one is I have a hierarchical data which consists of many sublevels based on a user question. I need search which nodes contain the tokens present in the question. Is Neo4j GraphDB apt for this use case? Absolutely. I mean, we love hierarchical data, and Neo4j is an excellent tool to go about using if you have a use case which uses hierarchical data. So yes, that's doable. Cool. Any more questions before I jump on to the next one? Awesome. Cool. Let's move on to our unstructured data. Now, we know this for a fact that structured data is super easy to work with. Doesn't need too much of efforts. But unstructured data is something which is super difficult to work with, because the data could be in multiple formats. It could be in multiple, when I say multiple formats, I mean it could be text data, it could be emails, it could be your social media posts or images or videos in that kind of format. But within that, also the structure keeps changing. So your text files maybe will have multiple structures. So one text file will have one structure, another one will have another structure. But how do you make sure that everything is um, consolidated and given a nice one structure to everything? So that's where graphs comes into picture. So uh, So we have learned about vectors and embeddings already, but these vectors and embeddings can also be used to represent unstructured data, which makes it easier to identify similarities and search for our related data. And as I said, graphs are super useful, super powerful when we want to represent and analyze this unstructured data. For example, you can use these vectors to find correct documentation to support a customer query, and a graph to understand the relationship between the products and the customer feedback. Or maybe a customer purchase. So let's say a printer company has multiple documents for each of its product. Now, based on customer asking, hey, tell me, how do I troubleshoot my printer? This is what I'm facing as an issue. It can go back and see into the graph what kind of relationship exists between that customer and which kind of printer that was purchased, and then further go to the right document, documentation or troubleshooting method, and give back the results to the customer, which are not generic but rather tailored, specific to the printer that the customer had purchased in the past. So that's the power of graphs and vectors together. Now, when we talk about unstructured data, we also talk about chunking as a concept. Uh, with these vast amount of data, it's difficult to process them in a single go. That's why we break them into smaller or more manageable chunks, which are helpful for us to process later on. And this process is called as chunking. There are countless strategies for splitting text into chunks. The best approach depends on the data and the problem you're trying to solve. So I'm not going to depth of what are the best chunking strategy or method. You're free to use any of it, but ultimately, the process means you take the large amount of data, break it into small data chunks, and then use it for processing further. Okay, so next in this particular workshop, we're going to import some unstructured data and split it into chunks. Okay, let's jump on to the next one. So now that's where our real GraphRAG Python package will come into picture. Um, we will be using this particular file within our knowledge graphs vectors folder called create and embed chunks.py file. So I will be switching back and forth between my code editor to show you. So this is my create and embed chunks.py. So what I have is a text over here. Now this is just an experiment, or just more like um, a walkthrough of how it works. So we have already loaded our Neo4j-GraphRAG Python package. And this is the text that we're going to divide into multiple chunks. So we have to put a logic to first split the text into chunks, and then we also have to create embeddings from chunks. Now, if I go back, I use something called as text splitter, which uses a fixed size splitter that's available um, in our LangChain and GraphRAG package. So we have more packages, more advanced splitters as well from LangChain and Llama Index. But we're going to use a fixed size splitter. We're going to divide it into a chunk size of 100 with an overlap of 10. And we're going to just print the chunks. So once we put this over here, save this, and then we will be running this one access. So we have to run this in. So for now, we are just creating the text chunks and just printing them. That's it. So we can see over here, this is our first text chunk. This is our second text chunk. And again, if you notice that there is an overlap of 10 characters, and so on and so forth. So this entire information is divided into multiple of those text chunks. But the embeddings for these text chunks are not created. Of these chunks are not created yet. Sorry, my bad. I was on a different window. So you can see there is one text chunk over here. There is another one over here, and so on and so forth. So for the entire text, we have multiple of these text chunks, but the embeddings are not created. So in our next step, we will be using OpenAI embeddings to create embeddings for these text chunks. So we will be using this method called as text embedding, or rather this model called as text embedding 3 large. We're going to use this and update our script again, and we will run the script again. Now this time we are creating embeddings as well. That's a long embeddings for each of those text chunk. There is an embedding that exists, but these embeddings are not stored in the database yet, by the way. So these are just random on the go process where I'm showing you how do you create text chunks and then create embeddings for it. Okay, so that's what this exercise is all about. How do you create that? But we're not interested in just running it on the go, but rather how do you build a graph? So that's where we're going to dive into a concept first, which is called as knowledge graphs. So knowledge graphs, just a second, sorry. All right. So knowledge graphs are essential to many GenAI applications. And when we talk about vectors and graphs together, we of course talk about knowledge graphs as well. Now, what are these? These are specific implementation of a graph database, where your information is captured and integrated from different sources and representing an inherent knowledge of a particular domain. A very classic example that I love quoting always is your data is not sitting in silos in an enterprise, right? But it does seem like that the data is in silos. But if you use a knowledge graph, you will really feel that the data is not in silos. For instance, there could be one graph for your product information. There could be one graph for your customer information. There could be one graph for your, let's say, suppliers. There could be one graph for your, let's say, manufacturers or distributors. One graph for employees. Now, if you notice that the data is rather connected or rather interacting with each other, but we never feel or ever realize the data is not in silos, but rather connected with each other. And that's where knowledge graphs helps you understand that how the data is interconnected. So a customer could be purchasing a product, a employee could be servicing a customer, or could be assisting a customer in the purchase. The product is supplied by supplier. The supplier gets a product from the manufacturer. There's a documentation for the product, so on and so forth. So that the data is connected with each other ultimately. So as I said, knowledge graph breaks down your sources of information and integrate them, which allows you to see the relationships between the data. Um, Here, the chunks are also connected with the source. So, for example, if in the previous exercise, we created chunks for the text, and the chunks were also connected with the main source as well. That helps us in better retrieval. And there's another concept called as named entity recognition, which allows us to extract entities and relationships from these chunks. So from chunk one, let's say we extracted topic I, which is about, with topic I from the chunk one. And the same topic I is also in a reference from chunk four, but the chunk four was part of source P. And this topic I also relates to topic J, which was extracted from chunk 5, which is part of source piece. You see how the data is kind of connected with each other. Here's another knowledge graph that could represent Neo4j. Neo4j is a company who has a founder, Emil Ephraim, who's a person. This person also works at this company for sure. This company was founded in Melmo location. That's a location. So Neo4j also is located in Melmo, but Neo4j also has offices in other parts of the globe. We have an office located in London, and London is capital of United Kingdom, which is another location. And Neo4j is owner of Neo4j.com, which is a website. And there's a blog article which is published on Neo4j.com. There's a documentation which is also published on Neo4j.com. Now, this blog post, this article is part of this documentation, or this refers to this documentation, or this blog post refers to this database of the technology. And this blog post is written by, let's say, Emil Ephraim. So, and this blog post is also about my Neo4j company. So ultimately, this is how you see the data is kind of connected with each other. Okay, so we can of course use LLMs to create knowledge graphs as well. These text chunks can be fed into these models, which can further extract entities, relationships, and properties from the text and populate nodes and relationships in our knowledge graph. So in the next exercise, we're going to we're going to use a GraphRAG Python package to do this exactly the same. Okay. So we will be using the another file in this folder called build graph. So let's look at this file, this build graph.py. It's the same boilerplate code as we did earlier, almost similar, but it also had some information that we need to fill in. Chunk the text, embed the chunks, very similar to what we did in the previous exercise. But here is additional step, which is list the entities and relationships to extract, and then we extract these nodes and relationships as well, and then we create a pipeline and run the pipeline. Okay, so if I go back, we're going to use the same fixed size splitter. We're going to update our code by adding a fixed size splitter over there. Next is embedding the chunks, very similar to what we did in the previous one. Nothing changes over here. Now once we have kind of over here, find the chunks, do the chunking, do the embeddings. The next step is to list the relationships. Now, here is what we are putting a schema. So here we are defining a schema. We are saying the entities, if you find these entities, person, house, planet, or these kind of relationships, the potential schema could look like this. Person is son of person, person is heir of house, house rules planet, and person is member of organization. So this is what I want to use it as a reference for entities, for relationships, and my schema. And based on this, extract the nodes and relationships from my data. So we're going to use this particular function called OpenAI LLM, which helps us extract our nodes and relationships. We're going to use OpenAI GPT-4o to do that part for us. Now we can now we can run this directly, but we're creating a pipeline because it makes it easier to modularize this entire code. So we are creating a pipeline next. It is a simple KG pipeline function to create this kind of a mechanism. Now, this KG pipeline is instantiated with our driver, our text splitter, an embedder. Entities are mentioned, relationships are mentioned, a potential schema is mentioned, LLM is defined. From PDF, we are saying no, we're just going to run it for the text. Now, what is this text that we're going to use? Now, if I go back and run this, copy and paste over here. So we have updated the text a bit. For this particular text, I've defined some nodes and entities to extract and just create this and run it for me. So once I run this, oops, sorry about that. And then build graph. Okay, so in the previous exercise, we didn't inserted data into the database, but now with this particular exercise, we've also inserted data into our database. So now if I go back and see my chunks, I can just run this cipher code and see that there was a node that was extracted, there was another node that was extracted, a relationship was created as well from the text chunk. So that's how simple it is to extract nodes and relationships from my unstructured data. So this was my source. There was an embedding for it. There was another source. There's an embedding for it. Another text chunk, basically. And this chunk is also connected with the previous one. So there's a main chunk, then there's the next chunk. So there were two chunks, essentially. From this chunk, from both these chunks, there was this node called Lady Jessica. And from this chunk, it was Paul. And Paul is son of Lady Jessica. That's what we could make sense from the text that we had given to the LLM to feed in. So This is how you create chunks into the embeddings, extract nodes and relationships. I mean, define the schema first, extract the nodes and relationships, run the pipeline, and then store it in the database ultimately. Now you can try it out with the other chunks as well and see how it works. Now, there's a bonus challenge that's for you to create a vector index on embedding property of the chunks node. So we created embeddings, we created a vector index on the plot embeddings and poster embeddings in the previous exercises. Now you can also create embeddings on this text that's already there, the embedding property, for, which is nothing but the embedding for this text. And then you can use this db.index.query vector.query nodes, the same cipher procedure that we did earlier to do a search on this property. You can create a full text also on this chunks node, the text property on this chunk nodes, and then you can also run this db.index.fulltext.query nodes cipher procedure to search this property. Cool, awesome. So that's on the intro of what knowledge graphs are, how do you use unstructured data, and how do you create vector indexes. So we are done with the first module of this particular workshop. Now we're going to use the Neo4j-GraphRAG package further. But I will pause over here and see if there are any questions in the chat, in the Q&A section. Sorry, the connection to Graph Academy is very unstable. While I still have the access to the Graph Academy website, I want to try myself after the workshop. Yes, definitely. So this particular URL, the Graph Academy portal, will be live throughout. You can test as many times as you want. Apologies if you're facing some connection issues. While that's not the ideal experience that we want you to have, but apologies on that. The sandbox might be a little buggy today. But you should be able to run everything fine later on if you want to try it out, test it out. So sorry, apologies again on that. The OpenAI key would be live until the end of the day. So make sure you make the use of it, and then tomorrow it will get disabled. Okay, is it possible to maximize the screen as we are unable to view it properly? Yes, definitely. Thank you for that feedback. I just noticed that I'll make sure that I maximize my screen and you can see it properly. All right, please repeat how to create embeddings. Okay, so are you referring to embeddings for the chunks? If that's what I'm guessing. So we used an embedding model from OpenAI called Open Text Embedding 3 Large. Let me see if you can see my screen. So we use this particular embedding model over here. Text embedding 3 large. That's the embedding model that we use, and then we just call in the OpenAI embeddings function. These are all pre-built functions that we do not have to spend time in building. And using these functions makes our life easier. In the previous exercise to this, we used the same thing for all our embeddings. We created an embedder. We initialized an embedder basically. Sorry about that. Okay, can you please share the Python code for reference? Actually joined a bit late. So Siddiq, entire code is available on our GitHub repo. So if you go to the first exercise, set up your development environment, you will see there's a link to the GitHub repository, which has the entire code. So all the entire code is existing in this GitHub repository. And as I mentioned earlier at the start, you have two options to run this particular exercise. One is either in open and GitHub code spaces, where you do not need to set up any environment except for creating a copy of .env file. But if you want and you have everything installed on the local machine, you can run on local system as well. I mean, you just need a Python installed on your local machine. So if Python is installed, then you're good to go. You have to just do git clone and then install the requirements, and that's it. Once you're done, you should be able to run everything that we already discussed. Okay, how can we access the recordings of the session? Well, the recording would be available on YouTube, if I'm not wrong. But yeah, it should be available on demand as well on the page. I think Samriddhi can answer this one on how do we access recordings for the session. Okay, while Samriddhi is answering that, just to let you folks know, there is a pop-up that might have come to you for this practitioner's guide for building knowledge graphs. It's an amazing ebook that I will definitely suggest you to refer to. Um, yeah, I mean, make use of this opportunity. Go ahead and refer to this ebook on building knowledge graphs, a practitioner's guide by Jesus and Jim. These are two amazing folks, and Neo4j. Um, yes, this pop-up will get removed in a while. So yeah, just letting you folks know. Uh, Go ahead and check out this ebook as well. Okay. Let's see. There's one more question. Should we be doing the hands-on while you are explaining, or we'll do it later? Well, it's up to you, Nikhil. If you want to follow along, you can, or you can run it later. It's up to you. How long this API key would work? Well, I am not too sure, but hopefully it should be available until the end of the day. But on the safer side, I'll suggest to use it in the next couple of hours after this workshop is over. It seems graphs are automatically created using embeddings. Yes, that's right. So the GraphRAG Python package automatically creates those embeddings. So when we ran this particular code, it extracted entities and relationships and created graph for these. Once it identified these entities and relationships, there would be, of course, some junk in the text, but it ignores the rest of it and just keeps only the relevant information that it needs to create this kind of schema for my graph. Okay, let's jump on to our next part, which is our GraphRAG Python package. So in this, we will learn how to use various retrievers. We have a bunch of retrievers like vector retriever, vector cipher retriever. There's hybrid retriever, hybrid cipher retriever as well. And there is text to cipher retriever. So there are essentially 5 retrievers that we're going to touch base in this particular workshop. Well, there are a bunch of more retrievers as well that's available in this package, but we're going to just touch base on these 5 retrievers for now. All right, let's go. So in retrieval augmented generation, we know that we use something called as vector search to find semantically similar results from the query that someone is putting in, extract relevant information, pass it on back to the LLM with the prompt the user asked, and it generates answers on the provided documents. It's much more accurate as compared to using a regular LLM, a foundational LLM, foundational model to extract information or to get results from LLM. So we use a method called vector retrieval to, to kind of find the semantically relevant result. So here we're going to use a vector retriever in this particular exercise. So we have already built a knowledge graph by extracting entities and relationships in the previous text. In the previous exercise, we will enhance our retrieval capabilities now using this. We're going to perform a semantic search, which enables you to find nodes based on the meaning of the content rather than just the keywords. So how it works, there's a query embedding. So each query, your user query, gets converted into a vector using an embedding model. And then there's a similarity search that happens between the query vector and the embeddings that are already stored into the database. The top relevant results are retrieved. So we have already done that. We have already seen that happening. But how it happens and how it works with our GraphRAG Python package is what we're going to learn and see right now. So let me switch back to my GitHub code spaces environment. So we will be using over here this vector retriever. Now it's very simple. You have to just initialize the embedder for our query vector, initialize our vector retriever, and then just use the retriever. As simple as that. Now, if I go back, this is what my embedder looks like. We're going to use a different embedder this time. We're going to use text embedding ADA002 model from OpenAI for embedding our query. We're going to initialize this vector as well. And then we're going to initialize this vector with the index we have already created, which is movie plots. Okay, and then we're going to use this retriever and say, the query says, give me 3 films where a hero goes on a journey. Now, if I go back and put it over here, if you notice over carefully, we are not passing any movie title. We are not passing an exact plot also. We are saying that hero goes on a movie or goes on a journey, finding something similar, but give me 3 films for that. So what it does is it goes back, does the RAG search, vector RAG search, finds relevant movies which are similar to this. So if I run this particular, okay, so these are the 3 movies which are having similar plot as a hero goes on a journey. Last Action Hero, The Never Ending Story 3, The Wizard of Oz. So these are 3 movies I've got. So this is what vector retriever is all about. Very similar to what we did earlier, but now instead of doing it in the console, we are doing it using our GraphRAG Python package. Um, there are tips to effective use. You can use consistent embedding. So make sure that your query is and your node embeddings are using the same embedding model that ensures compatibility. If you're using an embedding model for query as a separate one and embedding as a separate one, node embeddings as a separate one, then probably there's going to be a mismatch. Property retrieval as well. I mean, utilize the return properties argument and result formatter to retrieve and transform the desired properties effectively. It's again optional, how you want to retrieve the results and how you want to kind of format your results as well. You can always adjust your top k value um, to a higher value to improve chances of retrieving relevant results as well, because it uses this retriever uses an approximate nearest neighbor algorithm at the end of the day. Okay, so what if we want to find out for a specific actor? I know that give me 3 films where a hero goes on a journey, um, and where an actor is, let's say, Robert Downey Jr., right? So I want to be very specific over here and go and try to find out for a specific actor. Now we know from our database and that we have done that uh, movies are also connected to actors. There's actors also in the movie, or there's a bunch of information. So in those scenarios is where our vector retrieval with graph traversal comes in handy. So what it does, it combines a vector similarity with cipher queries to really retrieve relevant nodes from your Neo4j recommendation dataset. All right. So if I run this is just pure cipher right now, where we want to find all the actors that acted in the movie Jumanji. So in Jumanji, we know there are 4 actors that acted in. Now, when to use cipher, vector cipher retriever, when we want to combine our filtering and similarity. We just don't want to do similarity. We also want to do filter. When you need to filter nodes based on certain properties or relationships before you perform your similarity search. It's also good when you have structured and unstructured data together. So you can retrieve information from structured and then go on to the unstructured data, text data as well. And of course, advanced querying. So you're acquiring complex retrieval logic that leverages your cipher capabilities alongside your vector similarity. So let's go back to our code spaces, and there's another file called vector cipher retriever.py. So it's very similar to what we did in the previous one. We're going to initialize the embedder, initialize our vector cipher retriever, and use this retriever. So for initializing the embedder, I'm going to use the same embedding model, and then we will be initializing our vector cipher retriever. Now that's where the things changed a bit. Here we are not just creating a retriever and then querying it on the movie plots, but we are also having a retrieval query additionally. So a retrieval query is what we had put in, that this kind of a pattern to be matched, that actor acted in nodes, and then return title, uh, their plots and their actor names as well. And then we're going to use this retriever. So over here, the query has changed a bit now. So now instead of talking just about the movie plots, we are also talking about the actors. So we want to find out the actors in the movie about the Magic Jungle board game, right? So ultimately, it should retrieve me all these 4 actors that acted in movie Jumanji. So it should first find the movie Jumanji, tries to extract the actors, and then give back the result. Okay. So if I run this particular code, so actors in the movie about Magic Board game, now it is found out, okay, the movie is Jumanji. These are Robin Williams, Bradley Pierce, Kristen Dunst, and Jonathan Haidt. That's that's how amazing it is. Sorry, I was on a different screen. So we were asking actors in the movie about the Magic Jungle board game. We were not asking find similar movies as Magic Jungle board game. We are asking actors in that movie. So it has to first find the movie as well, tries to find a connection between movies and the actors via this retrieval query process. So that's what changed in this entire scenario in vector cipher retrieval. Now you have to identify when you want to use it. There are cases when you want to go beyond simple similarity search and you want to do a filtering as well. That's when you should use it. So I'll leave this to you to go back and read more, but this is what vector cipher retriever helps in achieving. Okay, now moving on next is our hybrid retriever. And one of you asked me that how does it rank between a vector and full text? So if you recall, we talked about hybrid search in when we were introducing full text search. So a hybrid retriever helps in combining your vector search and your full text search. Um, so how the process works is, let me just zoom in a bit, is something like this. So when I use it, ask query, there's a vector search that happens, and then there's a full text search that also happens. Now, in the vector search, we get some nodes and their scores. And similarly, in full text search, we also get matching nodes and their similarity scores with the user query. Now, what we do is we divide each score by the maximum vector search score for a vector search. And same thing, we do it for full text as well. We divide each score by the maximum full text search score. Once we do that, we get the new scores for each of the retrieved nodes. Now, once we get these retrieved nodes, we combine and reorder by the score. So for the top, and then we return based on the top k nodes. So for example, here there's one, and then probably this is also the top three results. So that's how we re-rank them, and then we give, okay, these are the two probable results that are mostly similar to what you're asking for. And so this is how the ranking mechanism works in a hybrid search, hybrid retrieval mechanism, where we combine a vector search and a full text search. Okay, so we will be using a hybrid search as well. Now, when to use a hybrid retriever as well. So when to use, we'll come back in a while. So let's see how the hybrid retriever looks like. Again, very similar, 3 steps: initialize your embedder, initialize your hybrid retriever, and then use this retriever. So we're going to use the same embedding model. Now we're going to initialize our hybrid retriever now. Now you notice over here, earlier we were just doing a vector index. We're searching on the vector index. Now we added a full text index as well. And then we will be using this retriever. Now, if you recall, when we introduced the term hybrid search, we also talked about, okay, if I want to find exact references of 1375 Imperial China, how I would preferably using a hybrid retriever. And in those cases is where hybrid retriever comes into picture. I want to find the movie which was set in 1375 in Imperial China. So if I run this, let's see what kind of results I get. I'm hoping I should get Musa the Warrior, which we saw earlier in the previous exercise as the top result for sure. So name of the movie that was set is Musa the Warrior. So that came in perfectly fine. So our hybrid retriever combined our vector search and our full text search and gave back the result to us. Okay, let's move on to the next one. Now, similar to what we did with the vector cipher retriever, if imagine we want to retrieve actors in this particular query, we want to retrieve what are the actors in the movie that is set in 1375 in Imperial China. I want to go a step further. I want to use a graph traversal now. So that's where hybrid cipher retriever comes into picture, where um, I know that Musa the Warrior has, let me just zoom out a bit, has following 4 actors. And if I want to find actors who acted in the movie with certain plot, I can find the movie and then find the actors over there. Again, similar to vector cipher retriever, we do the same thing over here as well. So let's jump onto hybrid cipher retriever. And then we initialize the embedder over here. We initialize our hybrid cipher retriever. Now, nothing changes as such. If you notice, we still have the retrieval query as well. This vector, other than that we have added a full text index now in the retriever, as compared to having just a vector index in the previous vector retriever cases only. Okay, and then we will be adding our query and then using this retriever. So now we are trying to find the names of the actors in the movie set in 1375 in Imperial China. So if I run this one, let's see the results. Okay, so actors in the movie. So first it identified the movie, then it identified the actors based on combination of full text and a vector search. Okay, these are the actors in that particular movie. Lovely. Okay, now before I jump on to the next one, I'll quickly pause and see if there are any questions that you have. Can we close this? Okay. I want to work on multiple documents. Is it possible to work on specific documents from overall embeddings for the multiple documents to build a graph? And yes, definitely, you can work on multiple documents. It it can retrieve information from those multiple documents. So you, of course, have to do some chunking um, uh, for each of your documents. So first step is to do chunking. Um, do the embeddings, store those embeddings into the graph as a graph basically into Neo4j, and then you can run maybe based on what you're looking for. Maybe you want to do a vector search only, you want to do a vector cipher search, you want to do a hybrid search or a hybrid cipher search. So it's up to you. I hope that answers Edward. Okay, moving on to the next question. A practitioner's guide is from O'Reilly, which seems needs subscription. Is this available in any other location or need to buy? Okay, I need to check. I think so. It is. I think it's only available on that particular link. Let me just check once. Give me a second. I think probably you need to buy that one. Uh, yeah, but there's another guide over there that you can probably use. It's a free resource. It's a developer's guide, how to build a knowledge graph. Um, if you want, you can check that out as well. Uh, the O'Reilly one is much more detailed. This one might be a little overview, but this is much more detailed. So up to you. Let's look at the next question. Do we need to learn Cypher to visualize knowledge graph? That's a very excellent question, Prasanta. So well, if you want to use vector cipher retriever and hybrid cipher retriever specifically, yes, you have to learn cipher um, to visualize the graph or rather retrieve results. I mean, if you know that what graph it is, and then you can write a cipher code, you can probably use a hybrid cipher retriever and vector cipher retriever. It's pretty great with that use case. The next section, which I'm going to jump to after taking these questions, is text to cipher, where if you do not know cipher and you want to convert a text to a cipher automatically via LLM, you can use this text to cipher instead, which can help you retrieve results from the graph. So it will convert a text to cipher and then retrieve results. So I'll come to that in a while. But yes, you it's always good to learn cipher. It's not that difficult, to be honest. It's super easy, super simple. It follows a SkyArt style syntax. You can learn from it from Neo4j Graph Academy portal. So go to graphacademy.neo4j.com, the portal that we are using right now. There are a lot of Neo4j fundamental courses and Cypher fundamental courses also, which can help you understand how and when to use Cypher. Okay, the next question is not clear about the full text search under hybrid retrieval. Okay, so we use a full text search when we want to search for specific keywords, right? Recall when we were discussing full text search, we also introduced the concept of hybrid search, where it combines the semantic and also the exact keyword matching. So when we want to find a movie which is set in 1375 in Imperial China. Here, I want to be very specific about the year and also the location. If I could be vague and say that, oh, hey, name the movies set in 1375 in Imperial China and don't do a full text search, then it tries to find the plots which were set somewhere in China or near China, or might have the word imperial in it, or might have the year 1375 in it. So it will miss out on the exact reference of 1375 and imperial and China in the movie plot. So since I know that this kind of text already exists in my database, I can easily retrieve it based on full text search. So this full text search helps me give that exact keyword reference, and then based on that I can use a vector search as a combination and get the right movie. Once I've got the movie, I can use the retrieval query in a vector cipher retriever case to find all the actors in that particular movie. I i hope this answers now. Okay, moving on to the next question. What are the main use of retrieval query? For every case, do we have to give the retrieval queries? Well, no. So retrieval query is primarily used in a vector cipher retriever when you want to retrieve results from a graph traversal as well. If you feel that you do not want to use a graph traversal and you're good with just the regular vector plus full text search, you don't want to use a graph traversal, you can just skip that retrieval query. If you notice, if whenever when I'm using cipher retrieval, that's the time only when I'm using this retrieval query over here as a parameter, as a variable as well. Here, when I'm using retriever, hybrid retriever without any cipher, I'm not using a retrieval query because I'm not trying to find the actors in the movie. I'm just trying to find the names of the movies that are set, name of the movie that is set in this particular context. Versus in this, I'm trying to find the name of the actors. Now, since our embeddings are done on movie plots, it will not have the actor information. That's why hybrid cipher retriever is better in such scenarios where um, I my embeddings do not have that information, but my graph might have that information. So in those scenarios is where the cipher retriever comes in handy, and then this retrieval query can help you retrieve results from the graph that exists in the database. Okay, I will mark these as answered. Moving on, next question. Is OpenAI embedding free source or a paid one? Well, it's a paid thing. I mean, you need to have an OpenAI account, a billing account, and get an API key. Um, Unfortunately, it's not free. But yes, you can, of course, convert this code. So we are using OpenAI, but you're free to use any other open source LLM as well, open source embedding models as well. We support almost all of them. So if you want to use it with Olama, you can use the open Olama's downloadable models. You want to use that, you are free to do that as well. Um, this workshop, we are just showing it how it works with OpenAI. But again, you can use it with any other LLM model also, which is free and open source. It's totally optional and up to you. Okay, can you please share the code repo link here? Well, the code is available in the GitHub repo that we cloned earlier. So if you follow the steps correctly, you'll see in the very first step where we had to set up your development environment. Here, there was a link to the GitHub repo where all the code was already published in this repo. Just for the sake of it, I'm pushing the link to the GitHub repo again over here. And we'll publish it as well. Okay. Let's look at the next question, which is I would like to build a RAG pipeline. Hope this master session guide me to develop the same Azure, Databricks, LLM, Neo4j, or do I have to refer any of the session? Those are available in Neo4j. Please guide. Well, this particular session will help you build a RAG pipeline with GraphRAG Python package. So what we covered so far is some of the introductions and core concepts about knowledge graphs, unstructured data, and vectors. And then we dived into some of the retrievers, which is vector retriever, vector cipher retriever, hybrid retriever, and hybrid cipher. The remaining two modules are text to cipher and multimodal application with vector cipher retriever. Um, so we are not covering up your expectations on Azure, Databricks, LLM, Neo4j stack. Right now, probably you would have to refer to other sessions, other resources that's available on your 4J YouTube channel or other portals for that. I hope that answers. Okay. The next question is how different it is when using Neo4j-GraphRAG versus using Neo4j with LangChain. Well, very good question. I had used Neo4j with LangChain earlier. Um, it it's a it's a little, I'll not say difficult, but it's it's a lot of work. The more lines of code, there's more work to be done. You have to give some prompt templates and integrations need to be there. You have to ensure that everything is there. So ultimately, it is this text to cipher or anything. I mean, GraphRag Python package you can integrate with LangChain as well. But it makes your life a little easier, as is what I would say. You can use Neo4j with LangChain, but then doing GraphRag on top of it, you have to build your own retrievers. The retrieval mechanism may not be that smooth, that great. But if you use this GraphRag Python package, your retrieval mechanism might be much more smoother as compared to what you would do in case of just doing it with LangChain. I mean, there's no harm. I mean, you can. I had built things earlier when this GraphRag Python package didn't exist. I was using just Neo4j and LangChain. Works out well, but then retrieval process was not that amazing, to be honest. Um, Converting your natural language to cipher and then cipher querying and then retrieving and giving you results was not that amazing. Um, that's what I had felt and realized. But um, with this package, it made my life easier, at least for the retrieval. I just have to call in these retrievers. These retrievers are simple, easy, not much efforts needed to call these retrievers. And you look at the number of steps have reduced. So you just have to initialize an embedder, your vector retriever, or vector cipher, whatever it is, and then just use the vector or use the retriever. That's it. I mean, that's how simple it is. So again, no harm in using Neo4j LangChain. People are still using that, but it also depends on your use case and how efficient you want to, how efficiently you want to retrieve the results or what kind of results you want to retrieve. So I'll leave the call to you to figure out which one works best for you. I'll not bias you with anything for sure. Okay. There's one more question which says, please suggest AI certification that covers most of AI concepts in CraftDB in Neo4j. I've been certified with Neo4j Professional before, and now I want to get into AI certification. Well, Nehal, we do not have a certification per se yet for GenAI plus Neo4j at this point of time, but there are a bunch of GenAI courses. Once we're done with this workshop, somebody is going to share the link to those GenAI courses as well. She's going to publish in a while after we are done with this particular workshop. So you can use that as a reference point and start your journey for using GenAI with Neo4j. So we do not have a certification yet, by the way, but we do have these courses that you can take up. All right, so I hope this answers, and then we can move on further. or I can wait for next couple of seconds and see if there are more questions coming up. Let me grab some water meanwhile. Okay, no more questions. Let's move on. All right. So in the previous exercises, we saw that we had to write a manual cipher code, which might be a little difficult for those who do not know cipher, or do not, or just simply like feeling lazy not to write a cipher code. So this retriever or this approach basically eliminates your need to write a manual cipher. Um, and then you can just use this retriever, convert your text to a cipher, and return results. So for example, if my query is return the first 25 nodes on the graph, the text to cipher will convert it into a cipher, which looks like this: match and return in limit 25. Very simple, right? So if I have to run this particular snippet, it says match all the actors. Uh, so match actor with the name Hugo Weaving, who acted in the movie. So I want to find all the movies in which Hugo Weaving had acted in, and all the titles of the movie. So these are all the titles of the movie in which Hugo Weaving acted in. Right. Now, when to use text to cipher? Of course, when you want to avoid manual cipher query writing. There's a natural interaction. You want to allow users, you're building a chatbot, you want to have a natural interaction. User asks a question, it converts to cipher. As I said, just giving an example earlier, you're chatting and then it goes and converts to cipher, it takes the results and gives back to you. Which was difficult back then when I was using Neo4j and LangChain together. So relying solely on LLM's capability to do that text to cipher conversion. But since this text to cipher is trained on a foundational LLM, and then we created a separate LLM called text to cipher LLM on top of it. So the results are much more fine-tuned. It's a fine-tuned LLM in any case, so the results that you're retrieving are much more crisper as compared to using a regular foundational LLM for retrieving your results. So let's see how it works. So let's switch back to our text to cipher code, and then we see there's an initialization process, and then we just have to retrieve it. So let's add our initialization, where we are saying a bunch of things. We are saying create a LLM object. We're using GPT 3.5 Turbo over here. We're specifying a Neo4j schema. This is how my schema looks like. There are a bunch of node properties like person, movie, and these are the nodes. These are the properties. The relationship properties looks like this. The relationships looks like these, and then we're also saying that based on, one second, let me see, how do I wrap this one? Okay, so we're giving an example over here. We're saying if the users ask that which actors starred in the matrix, you just have to do a query which says match acted in, where the title is the matrix, and return the person name. We just call this text to cipher retriever function, which has a driver parameter, it has LLM, it has Neo4j schema, and then some examples that we had already given. We have given just one example. You're free to give in more examples as well to make it much more fine-tuned. Now, the next step is to just retrieve the results. So I use this query which says which movies did Hugo Weaving star in. So if you recall, we already ran this query, so we should get some movies names. And once we run this, let's see what result we get. Let's run this one and it's to cipher. So the backend, what it will do is it will convert this particular query into a cipher query, and then the cipher query is ran against the database and gives back the results. So these are the bunch of movies that Hugo Weaving acted in. Sounds good. Lovely. Great. So that's what text to cipher is all about. There, of course, you can provide a Neo4j schema to improve your query accuracy. It's optional. If you do not define the schema, it might go haywire and then might not give you better results. So yeah. Then you can handle errors as well using text to cipher retrieval error function. If there's an error in the generated query, you can fix that as well. All right. So as I said, you can add more example queries to guide the LLM in generating accurate cipher responses. So that's it about the 5 retrievers that we talked about: vector retriever, vector cipher retriever, hybrid cipher retriever, and text to cipher retriever. The last step is where we're going to combine the functionality. We're going to build a multimodal application with vector cipher retriever over here. So so far what we saw is just using it in the Python applications, but how do we build an application, Python scripts, but how do we build an application which is multimodal and can also help us achieve what we see as a GenAI application out there, that hey, you can chat, you can do this, you can do this, you can do that, and so on and so forth. So let's get started. So we're going to use this title called Homeward Bound: The Incredible Journey. These are the actors acted in this particular movie. Now, we already have a particular script, which is multimodal app.py. We're going to switch to that. We're going to initialize the embedder. So here in this, we're going to use a combination of a text and visual data. Notice we were just working with text for now. So now we have added in a visual data concept over here, which is where we're going to use the image embedding model to find the posters of a movie with a specific plot, or with a related plot. So next is what we're going to initialize our vector cipher retriever. So what we are doing over here is we are defining our poster index name, which is movie posters. There's a retrieval query, which is just to return our title, plot, and the poster URL. And then there is a vector cipher retriever, which has our vector index, which has a retrieval query and everything. So as I said, we want to find a movie where in the poster there are only animals without people. Right here, we are not finding movie names. Here, we're finding the poster. So it has to also do a combination of image and text over here. Right. So once we run this, let's run this one now. And it should give me all the URLs or get me all the movies. It runs a sentence transformers, by the way, in the backend. So it takes a while to fetch in the results. So these are the movie titles we have got. We have got the posters as well. So if I go over here, this is Apollo 13. There's a plot that's mentioned. There's a score that's mentioned. And then there is this movie poster. I mean, it kind of felt that there are only animals here. Yeah, or there's the next one, which might have only animals. So yeah, this one would have only animals. It kind of didn't do a good job in removing this, but yeah, that's okay. But ultimately, this is how you build a multimodal application. You can combine your metadata from, or your information from your posters, store it in the embeddings, then retrieve information in the form of a multimodal application via this vector cipher retriever. Awesome. So coming back, this is where we come to an end, and as I said, we use something called as clip VITB32 model from sentence transformers to generate our image embeddings. It captures visual features of a movie poster for semantic similarity, and then we ran it against our existing movie posters that already have a vector index. And then this is the type of multimodal integration that we have. Unfortunately, we do not support multimodality within graphs itself. So they had to work with text so far, text in the entire scenario, because we do not store, um, like we do not support multimodality at the end of the day. Awesome. So yeah, that's it about the workshop. This is a quick wrap. Congratulations on completing this workshop. Um, and then you can, as I said, that you have learned about these vector retrievers, vector cipher retriever, hybrid cipher retriever. We built a multimodal application. We learned what are the advanced retrieval strategies using our Neo4j-GraphRAG Python package. Um, Now, this is a quick recap on what needs to be used or choosing the right retriever. So when you have a vector index, you can use a vector retriever. When you do not have a full text, and you do not need a full text or a manual cipher, automated cipher over here. So vector cipher retriever needs a vector index and also manual cipher. You do not need a full text or an automated cipher as well. And a hybrid retriever needs your full vector index and a full text index as well. And your hybrid cipher retriever needs vector index, full text, and manual cipher. And text to cipher is your automated cipher. So essentially, what I have seen and witnessed, your hybrid cipher retriever is mostly good in retriever use cases, but it depends whether your vector cipher retriever can really do the job. So in simpler use cases, probably you would preferably want to use vector cipher retriever, and maybe a little complex use cases, I would probably suggest to use a hybrid cipher retriever. But again, it varies on your use cases. So feel free to test it out, experiment on it, and see how the results vary from a vector cipher retriever versus a hybrid cipher retriever. We'd love to hear the responses and feedback on it. Feel free to reach out to me or to anyone in Neo4j, and we'll help you in taking it forward. Awesome. So, oops, what was that? Okay, I'll stop over here. We do have some time for Q&A. Somebody has already shared the link to our courses. These are GenAI courses. I can probably push them again in the chat. So these are other GenAI courses that you can explore. There's Neo4j and LLM fundamentals, introduction to vector indexes and unstructured data, using Python, using TypeScript, building knowledge graphs with LLMs. So I'll definitely recommend to go ahead and check out these courses as well. The one that we did today was specifically on our GraphRAG Python package that was launched recently. I have also published a GenAI courses link for you folks if you want to check it out. Okay, let's take up some questions. Question is there any integration of Neo4j or Neo4j GraphRAG with no code packages? Um, can you elaborate a bit on no code packages? I have not heard of no code packages. Are you referring to like a low code no code environment, just where you do not have to code? If that's the question. Well, we do have a tool. I'm not sure if I'm at the liberty to talk about this tool, but we do have this. I mean, when I say I don't have the liberty to, it basically means it's outside of the scope of this workshop. But I'm super excited always to talk about this tool. So this tool is our LLM graph builder tool. You can read more about it over in this particular URL. I'll share this URL as well and publish it too. So this tool can help you automatically build a knowledge graph without writing a single line of code. So if you want to learn more about it, just head to this link, play around with the tool, and share your feedback. Uses various LLMs. So I think if that's what it is about. Init in. I have not used init in, by the way. Um, so yeah, I won't be able to comment on that question. Whether you, but if you're looking for creating your graph visualization schema, is what I'm guessing, to just automate your workflows. Um, Probably this should be something. Let me just check. We haven't explored this one yet so far. But there's something around Neo4j MCP server to automate your workflows. I mean, if that helps. Okay, just moving on to the next question. 1 second. Yeah, okay. Can we visualize the retrieved answer of user question in the form of graph in output screen? Well, you can do that, but there's additional step that you have to do to ensure that you can do that. So we also have something called as Bloom, and there are a lot of visualization libraries that you can actually explore. But there is this graph visualization tool that we have called Bloom. I'll recommend you to check this out. This can help you achieve that you're looking for. You have to just make sure that you pass those responses via Bloom and then get the results. All right. So is there a way to inspect and improve on the white output? Uh, I need to check on that if there's a way. I think so. I mean, I haven't explored a lot on GraphRAG package much, but I'm sure you can have some more um, helpful console outputs and segments to inspect and improve on the white output. Um, if I'm not wrong, you can also connect it with Langsmith and then do some more introspection. So that's also another way to get more results, like to inspect and improve on the results. But it should be possible. Okay, why do we set the temperature for GPT? Set the GPT for temperature to 0. Well, you can change it. You can change it to different values and see the results. Um, just for this particular workshop, we set it to 0, but you can of course change it to any other values and see how the results vary. The results would definitely vary if you change the temperature from 0 to any other value. Can you please suggest a couple of impactful use cases that can be done after this course? Well, the use cases depends on you. What kind of use cases? Let me just think about it. I mean, for sure, chat applications are pretty good to build. Now, for chat applications, you can think of varied use cases. Um, I'm actually out of thoughts in terms of any specific use case, but there are use cases on fraud detection. There are use cases on uh, cybersecurity. These are like top use cases for Neo4j, but GraphRAG in general can be implemented on any other use case also. I mean, one interesting use case which I of course mentioned earlier was I haven't thought a bit more on that, but was on the printer manuals and the customer's purchase history. Probably if you want to test it out and you find a data set which can give you this information about uh, let's say 5 6 printer manuals, then customers purchase history on those printer manuals. Maybe it's a good use case to just see how you can retrieve specific questions, specific results for the questions that the customer is asking. So that could be one of the use cases as well. So yeah, there are a bunch of them. I mean, try to see what kind of data that you have. If you can get some unstructured data and then you want to use it with Neo4j to do the embeddings and creating a graph structure out of it, that's where it could be some amazing use cases that can come out. Cool. Are there any more questions? We do have some more time before we wrap up. Are we all good? Creating data lineage using GraphDB. Well, this is out of scope for this particular session. I would suggest to check out the online resources. I can find something for data lineage using Neo4j. Well, this is definitely out of scope for this particular session. I, from a random Google search, I found this particular resource. So I'll suggest you to check this one. And there is another one. There's a video that we have it on our YouTube page. So you can check this one also about data lineage, as that it's definitely out of scope for this session. Okay. Any more questions? Anything else? I hope the folks had a good time. The workshop was useful. I would definitely encourage, if you have not followed today, to go back, follow the exercise. It's not that difficult, simple, pretty simple. The API should be available until the end of the day. Just use it wisely, by the way, and make use of it. Make use of the Graph Academy tool. Make use of this particular workshop as well. The content is going to be available throughout, so you can just refer to it anytime you want to. With this, I'll wrap it up, and thank you so much for joining in. Over to you, Samriddhi.
Thank you so much, Sid. Looks like we have one more question. How can we
Okay.
prune or recognize the graph so that better semantic search results are ranked against the full text search?
Well, that's a good question. There is a way to do it in the LLM Graph Builder tool without um, kind of manually doing it. It automatically fetches your orphan nodes and everything. So depends if you have just orphan nodes or you want to just reorganize the graph. If it needs a lot of reorganizing, I would suggest to do it directly within the Neo4j console. To go to the console, reorganize the graph, and then you can have better results. The best part about Neo4j is it's very the schema is very flexible, and you do not have to force yourself with a strict schema. So you can change and update your schema on the go. Uh, the moment you change it, the semantic search or your full text search will automatically update on its own. I mean, your results would fetch based on what you make changes to. So uh, if it's too much of work, I'll suggest to go and do it manually. Or if it's critical enough to not let an LLM do that for you, I'll suggest to do it manually. But yes, you can change the schema later on as well. How can we integrate other vector DB such as LansDB to carry out normal search along KG? Well, you can do that. I was checking out. There was an article, blog post recently. Let me just see if I can find that one. So maybe not specifically with LansDB, but I saw something with Quadrant DB, if you heard of Quadrant DB by any chance. So I saw this GitHub repo. I'm not able to find the link. Let me just see if I can find the link also. Uh, yeah, I think I found a link. So probably this could be something that you're looking for. So you can definitely combine a vector database and a graph database together. This is another link that I can share it with you. Oops, did I send? I'll just hit this one. I'll send you the link. 1 second. So that's the GitHub repo link, and the one that I'm sending now is it's one of the blogs on Quadrant's page on building a GraphRAG agent with Neo4j and Quadrant. So it's definitely doable. You can combine a vector DB and a graph DB together. All right. Any more questions?
All right, thank you, Siddhant, for such a great workshop. And for those in the audience, thank you for joining us today as well. I'm adding the link to our Neo4j Fundamental Workshop, which is happening on the 10th of April for those who have missed it. And looking forward to see you all. Have a great day.
Thank you.